Trigonometry, reciprocal trig functions. Let's start by looking at the graph of y is equal to sine x. It's a graph that you're already familiar with, and then we'll have a look at a few properties of the sine x graph, and then from there we'll have a look at its reciprocal graph. Y is equal to cosec x. So the graph of sine x, the graph goes through the origin. It has a maximum of 1 on the y-axis and a minimum of -1 on the y-axis. So if you're looking at the y-coordinates range from -1 at the lowest point to +1 at the highest point on the graph. So that's the range of the graph, -1 to +1. The graph repeats every 360 degrees. That cycle there repeats every 360 degrees, or every 2 pi if you're looking at radians. To get the graph for y equals cosec x from this graph, wherever this graph goes through the x-axis, so these points, you find that you will have asymptotes on the cosec graph. So the graph in red is for sine x, and everything for cosec x, the reciprocal graph, I'm doing in blue. So you have these asymptotes to begin with. When the sine x graph is above the horizontal axis, so here and here, the cosec graph has these distinctive U-shaped curves like this. And this cosec curve here is going towards this asymptote and this one here. And when the sine x graph is below the horizontal axis, then you have these N-shaped curves like this. So there you go. In blue you have the graph of cosec x, and as you can see, for the U-shaped curves, they come all the way down and they meet the sine x curve right there when the y-coordinate is equal to 1. When the y-coordinate is equal to 1. And the N-shaped parts of the cosec graph, they reach a maximum here, touching the sine x graph when y is equal to -1. When y there is equal to -1, those two graphs meet. The cosec graph also has a period of 360 degrees. So if you look at this point here on the cosec graph, the next point which is similar is here. That's 360 degrees between these points. So similar to the sine x graph, it has the same period of 360 degrees. This graph in radians would just look like this. So if you just cross off the degrees and start putting radians here, so that would be -pi, 0, pi, 2 pi. You can very easily convert the graph into radians. So you've got ½ pi there, -½ pi, 1.5 pi here, -1.5 pi here. Okay, let's have a look at the graph of y is equal to the cosine of x and y equals secant x. These graphs are similar, very similar to the ones that we've just looked at for sine and cosec. So this is the graph of cos x. It's symmetrical about the y-axis. Whenever this graph goes through the x-axis, for instance here, 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 and here, the y-coordinate here is 0, it's 0 here, here, and here. At these points on the cosec not the cosec, the secant graph, you will have asymptotes like this. And then, as before, the region on this graph where the curve is above the horizontal axis, you will have U-shaped curves, and below the horizontal axis you will have N-shaped curves. So these U-shaped curves here, and these N-shaped curves here. Again, these N-shaped curves have a maximum of -1. That's the maximum y coordinate. And the U-shaped curves have a minimum y value of 1 here and here. The graph repeats every 360 degrees or 2 pi radians. Now let's look at the graph of y equals tan x and its reciprocal graph y equals cot x. So starting with the tan x graph, and we know there are asymptotes on this graph. Tan x has a period of 180 degrees or pi radians. Wherever the tan x curve crosses the x-axis, so here for instance, the y-coordinate is 0, so there will be an asymptote for the cot x graph right there, another one here, where that curve is going through the x-axis, another one here, here, and here. This graph is looking a little bit too detailed for my liking, so I'm going to remove the red dotted lines that represent the asymptotes for the tan x graph, just for the purpose of clarity, so that you can clearly see what the cot x graph looks like. Okay, so we have this. The tan and cot graphs will cross each other whenever y is equal to 1 or whenever y is equal to -1. So the cot graph looks like this. And you can see that distinctive pattern repeating itself. So you have the graph of tan x and cot x. Both of them have a period of 180 degrees or pi in radians. Now you need to know how to sketch sine, cos and tan graphs and cosec, sec and cot graphs. And you need to know this both for degrees and for radians and some of their basic properties. A graphical approach to solving trig equations. Let's say we're trying to solve this equation here, that cos x is equal to 1/2, and we're only interested in those values of x which are in this range here, -180 degrees to 360 degrees. So on the same graph I'm going to sketch y is equal to cos x and y is equal to 1/2. Y is equal to 1/2 is just the horizontal line going through the y coordinate 1/2. So we have these two graphs, the cosine of x and this one here, y equals 1/2. The y coordinate there is 1/2. And if we look at the points of intersection where they're both equal to each other, 1, 2, 3, 4, at 4 places they are equal to each other. Now we're only interested in those solutions which fall between minus 180 degrees and 360 degrees. So we're looking for this solution, so the value of x here, the value of x here, and the value of x here. This one here is outside the range. We only want those between minus 180 and 360. So only solutions along here and nowhere else. So there will be 3 solutions. So from the calculator, if I do inverse cosine of a half, I get 60 degrees. So that angle is here, 60. So that's one solution. Because of this, the symmetry of this graph, that's 60, this one's going to be minus 60. So that's my second solution. And looking at the period of the graph, this solution here is 360 degrees from this one. So minus 60, which is the angle there, plus 360 is 300, so the angle there is 300 degrees. So we have our solutions. These are the values of x, which are solutions to this equation for values of x in this range. Now we're going to look at the graphical solution to this equation. Secant x is equal to 3. So on the same graph, if we have a look at the sketch of y equals secant x and y equals 3, so on the graph here we have secant x, these distinctive U and N-shaped curves, and we have the horizontal line y equals 3, and where they're equal to each other in these positions here, there's 4 there, but again we have to stick to our range of angles for x, minus 180 to plus 360, so between minus 180 and 360, so just that lot there, there will be 1, 2, 3 solutions. Secant x is the same as 1 over cos x. That's still the same, it was 3, that's still 3 here. If you work out the reciprocal of each side of this equation, you end up with cosine of x is equal to 1/3. And now you're able to go to your calculator and just do what you normally do. So inverse cosine of 1/3 is equal to 70.5 degrees. So x is equal to 70.5 degrees. And on our sketch here, that angle is this one here. So that's 70.5 right there. And by symmetry, because the secant graph here is perfectly symmetrical about the y-axis, if that's 70.5, then I know this one here will be minus 70.5. So minus 70.5. So far I have these 2 solutions, and this one here is 360 degrees away from this one here. So if I start off with minus 70.5 for this angle and add 360 to get the one on this side of the graph, 289 degrees. So this is 289 9 degrees. So that's my third solution there. And as you can see from this example, when you're solving equations involving reciprocal trig functions, you're not going to use, inverse secant on the calculator. That function's not here. All you have are sine, cos and tan, which means anything that's given to you in terms of cosec, you need to rearrange into sine. Anything in terms of secant, so change everything so you've got cosine, and change cot into tan. So for example, cosec, which is 1 over sine, so 1 over sine, that's equal to 5, and don't do anything to this. Now reciprocal both sides, so sine x is equal to a fifth, and then you can do inverse sine x, inverse sine 1/5 on your calculator. So you can do this, and what it will give you there is the angle x. So for instance, inverse sine 1/5, so 11.5 degrees, that's angle x. And you can do this in radians as well. If I wanted the same thing in radians, shift, setup, if I go to radians there, press equals, 0.201 radians. So for secant, which is 1 over cos, again don't change anything here. Now reciprocal both sides, so cos x is equal to, now remember, when you take the reciprocal, the sign of the number doesn't change. If that was negative, it's still going to be negative. Cot x is equal to 1/3, so cot is related to tan, so 1 over tan x is equal to 1/3, reciprocal both sides, tan x is equal to 3, and so on.